In section 4, we'll be looking at segments and angle measures that happen when we have secant lines crossing inside or outside of a circle. So a secant line is any line that's crossing through a circle in exactly two places. So it'll always go inside the circle. Now, if we're looking at intersections inside the circle, first thing we'll look at are the angle measures. The first theorems we'll look at are dealing with the arcs and their relationship to the angle that's formed in the middle. So if I look at these arcs A and B, one's bigger, one's smaller, if we add them together and divide by 2, we'll get this angle that's formed. Notice that this x would be the same as that x because of vertical angles. But that angle will always be half of the sum of those measures. This can be seen in this picture here where we have two secants coming together. Notice that I've got the measures of my arcs here and here. I've added them together, divided by 2. And notice the central angle here, no matter how I move this, it's going to match that sum. Now if it goes outside of the circle, that will change, but this is valid for when they are inside of the circle. So we can use that in a problem like this. Now they're asking for the measure of angle 2, but if we look at the picture, the angle that we can deal with is angle 1 because the arcs that are being cut off here and here where they cross has angle 1 in the middle here. So looking for the measure of angle 1, it'll be equal to 1/2 of the sum of the arcs, so the 20 plus 30, which would come to 25. Now this is the measure of angle 1, but we wanted the measure of angle 2, so we have to look for another relationship here. Since angle 2 is here and that forms a linear pair, we would know that the measure of angle 2 would just be 180 minus 25, giving us 155 degrees. The next theorem is about a secant line. Actually, this was from the last section, but I thought it went better here. Would be when this angle measure with a tangent line is formed. So this angle here will always be half of the measure of the arc. We can see that in this picture here where I have the measure of my angle, I have the measure of the arc. I'm dividing the arc by 2, and that's giving me the same measure there. So notice that my circle could go around to 360 degrees, but my arc would only go up to 180 degrees, so it's always 1/2 of that. You see that in this picture here. We want the measure of angle ABC, which is here, but notice that the arc that they've given us, AB, is actually this arc here. So to use this theorem, we need the arc that goes along with the angle we're looking for. Since this is on the interior over here, we need arc ADB. So we take that 102, we subtract from 360 degrees because we're using the whole circle there. That's going to leave us with 258 degrees, which would be the measure of this larger arc. And so using our theorem that we just found, the measure of that angle, so measure of angle ABC, will be equal to 1/2 of that outside arc, 258, which will come to 129. Our next theorem looks at what happens when the secants are intersecting outside of the circle. And notice with these we use a subtraction. So when it was inside we'll use the plus, when it's inside we'll use the minus. And the arcs that are being cut off, there's obviously a larger one and a smaller one. The larger one will be further away from the angle that we're looking at. So it'll be B minus A. Half of that will be equal to X. So you can see that demonstrated here. I've got my smaller arc and my larger arc. If I subtract them and divide by 2, it's going to give me a value that's always equal to this arc that's meeting outside of the circle. The same thing will be true for dealing with the tangent line with a secant, or if I have two tangent lines, then it would also work. Now notice with this one that if we're looking at these two angle measures here, since they actually make up the full circle when we're dealing with tangent lines, these two would be equal to 360 degrees. So even if I only had one of my angles, I could find, or one of my arcs, I could find the other arc by subtracting 360. So all three of these theorems are going to use the same formula where we take the arcs, the larger one minus the smaller one, divided by 2 will always give us the measure of the angle on the outside. So all three of those are the same theorem, which is why they've called them the same theorem, A, B, and C. Okay, so to actually use it, we'll look first at our picture, see what's being cut off by the arc. So we only want this part, and we want this part, AE. So if I'm looking for the measure of angle X, the angle on the outside will be 1/2 the difference of the other two arcs. So 120 is further away, so 120 minus 50, which would give me 70, and we divide 70 by 2, that's going to give me 35. In this one, we're dealing with a tangent line, but also notice this one has a diameter here. It's passing through, they want us to assume that this is the center of our circle. So the arc that we're actually looking for here, this one would be 180 degrees. So setting up our equation, we've got our angle over here. This is 45 degrees. So our angle is equal to half of the difference of our angles, 180 minus, and this is where the x comes in, the 10x is right here. So if I divide those by 2, that'll give me 90 minus 5x, or I could have multiplied both sides by 2. And then that will give me 5x equals 45 by subtracting 45, adding 5x. And dividing both sides by 5 will give us 9. So x is equal to 9. Now this could be useful in a problem like this. We have a satellite up above the Earth looking down, and we want to know what the arc measure is actually visible to the satellite. So we're thinking this as we want this small part here come around from P to R, and we're calling that x. Notice they haven't given us any other angle measures except for the satellite. And so to do this, we need to know that because these are tangent lines, this full distance around the circle, the red plus the yellow, those are going to add up to 360 degrees. So if we're calling this red arc x, then that yellow arc would have to be 360 degrees minus the red arc, the minus x. And so that's how we're going to get our two angles here. We'll set this up then. Our angle 10 is equal to 1/2 the difference of our angles. So the first angle there is going to be 360 minus x, that's the far side, and then the closer side is just x. I can simplify that then to get, I'm going to multiply both sides by 2 here and get 20. That'll give me 360 minus, so it's minus x, that's minus 2x. I'm going to move 2x to the other side by adding that, and I'm also going to subtract 20 here, and that's going to give me 340. And so my x will be 170 degrees. So this is telling us that the satellite can see 170 degrees of the equator